Hi everyone, my name is Amitish, and in this video we're going to dissect that limit over there, talk about what it is. It's a fundamental limit, and conceptually understanding it is going to help us understand the whole array of limits that come up in calculus. And this video is as I've taught freshman calculus at Princeton University. There's a very fundamental limit that I keep emphasizing and try to focus on how to understand this so we can understand similar limits as well. So let's dive right into it. So the first step is, in math, typically when we see something, people can give you a polished answer if they've already worked through it, but we want to just get into the head of someone who is seeing it for the first time, try to understand what this means. So limit x goes to 0 of 1 over x, it's basically what does 1 over x approach as x approaches 0. Okay, so what 1 over x approaches as x approaches 0. And if you draw the number line, you know that there are two ways in which a number can approach 0, right? So if you draw the number line here, you can approach, x can approach 0 from the left, or x can approach 0. So this is from the left, or this is from the right, right? So x can approach 0 from the left, or x can approach 0 from the right. Now, what usually, in limits that we study many times, it doesn't matter which direction you approach. This case is going to be a little different. We're going to see that. And what we want to do is just imagine some small values of x, okay? So 1 over a very small number. Now before we get into that, I want to point out that you can't just plug in x equals to 0. So limits are what the function approaches as x approaches 0, which could be the value at 0. But in this case, if you plug in 0 literally, you get 1 over 0. Okay, so I'm going to write that down. This is not an indeterminate form. If you've seen that terminology, it is not an indeterminate form. It's not what we call it, because we can actually figure out what the limit is pretty precisely in this situation. Whereas with indeterminate forms, when you have something like 0 over 0, the limit could be any number in some sense, and you have to dive into it. In this case, we'll get an answer, okay? But let's sort of think about, so we've got 1 over 0, which doesn't exist. You can't divide by 0. Whatever number you try to say that 1 over 0 is, well, that number times 0 better be 1, right? Just like if I divided, 10 over 5 is 2, what this means is that 2 times 5 is 10. So if I say this is question mark times 0 should be 1, but anything times 0 is 0, right? So there is no answer to this. So we say this is undefined, okay? So we can't just plug in 0. That's the first thing, okay? So that's number one. Always plug in into the limit first off. And if you're dividing by 0, then you need to think about stuff differently. Typically in high school or university calculus, people will give you contrived problems where you are going to be dividing by 0, because otherwise it's going to be easy. But we'll see this as an example and understand it. So we know that we can't plug in 0, but what we can do is plug in some values of x near 0 to get a feeling for the limit. So the first thing we can do is look at x approaches 0 from the right, okay? It may or may not be different or the same, but let's kind of do that, okay? It could be the same as x approaches 0 from the left, or it might not be. But what we can do is plug in some small values, okay? So x is equal to 0.1, x is equal to 0.01, x is equal to, I'm going to write it as 1 over 1,000, x is equal to 1 over 10 to 10,000, and so on and so forth, okay? So you can sort of imagine that x gets smaller and smaller, but x is positive, so it's approaching 0 from the right, okay? So what we can do now is we can plug in, 1 over x, 1 over 0.1 is going to be 10. Right? Because 0.1 goes into 1 10 times. 0.01, 100 times 0.01 is going to be 1. So you get 1 over x is 100. Then you get 1 over x is going to be, you can keep sort of going, it's going to be 1,000. Generally 1 over 1,000, 1,000 goes up top. So you can do this, I'll do it for this one. So 1 over x is equal to, my apologies, I shouldn't put a equal sign there. 1 over x is equal to 1 over 10,000, which is going to equal to 10,000. So you can see the pattern there, okay? So as x approaches 0 from the right, 1 over x is getting bigger and bigger and bigger, okay? So in math, we call this something, okay? We call this, the limit is infinity, okay? So in this situation, what we say is, and I'm going to sort of write it out here. Maybe I'll just kind of put a partition here. Limit x goes to 0 plus, this is a right hand limit. It means x is approaching 0 from the right, so x is positive. 1 over x is going to equal to plus infinity. Okay, so what this means is that the number 1 over x keeps growing larger and larger as x approaches 0 from the right, okay? So as you get close to 0, you get as large a number as you like, okay? That's what the means to say the limit is infinity. Now we've got that limit, but it's interesting that when you take the limit from the other side, you get something different, okay? So it's not just infinity, and this is a very fundamental point. So what happens from the other side, I'm just going to do the same table, and I'm going to replace everything with a negative number. So let me erase all of this and just slightly change things around, okay? So here I'm going to say x is equal to negative 0.1. Here I'm going to say x is equal to negative 0.01. Here x is negative 1 over 1,000. So you see that x is approaching 0 still. You know, it's negative of a very small number, so it's still close to 0, but it's from the left side of the number line. So we've got x is equal to negative 1 over 10,000 dot dot dot. And what happens here is 1 over x, 1 over negative 0.1, because you're throwing in the negative sign, you take 1 over that, the negative sign still persists, but it's the same answer otherwise. So you're going to get 1 over x is negative 10, negative 100, negative 1,000, negative this, negative 10,000, etc. So you're getting negative 10, negative 100, negative 1,000, negative 10,000. You're going to get sort of not bigger and bigger numbers because you're going to the left on the number line. You're getting smaller and smaller numbers. Negative of numbers that are going to infinity, right? So negative of numbers that are going to infinity, another way of saying that is negative infinity. So we write that limit x goes to 0 on the left of 1 over x is equal to negative infinity. Okay, that is what is called, that's a left-hand limit, that's a right-hand limit. So that's an evaluation of how these limits work. And you can actually now say, so this is actually, because the right-hand and left-hand limits are different, we would say the limit does not exist in this case. Okay, so this is what is called DNE. It does not exist because you're getting a different answer from both sides, so there is no consistent value the function is approaching as x approaches 0. Okay, so that's the situation there, but we have found the right-hand and left-hand limits. Now I'm just going to sum up by actually drawing. Okay, so we've sort of done this DNE, we've said it, DNE means, DNE stands for does not exist. Okay, so DNE stands for does not exist. Now what we're going to do is we're going to actually think about the graph of 1 over x. So this is something, we see in pre-calculus, but I deliberately avoided drawing the graph because I want to show you that, actually this is the way we find the graph in the first place. Okay, we sort of plug in these values like we did here and we get a feeling for what the graph is. So here, if you try to sketch the graph of 1 over x, you can kind of get a sense of what happens near x equals 0. So you first know, like when you sketch a graph, the first thing you want to do is ask, what is the domain of the function? Where is the function defined? So here the domain is all non-zero numbers. So the domain of f of x, so I can write the domain of f of x equals to 1 over x is all non-zero numbers, which in interval notation you can write as minus infinity 0 union 0 infinity. Minus infinity 0 is all numbers that are less than 0. So between minus infinity and 0, so it extends arbitrarily to the left-hand side, the number line. So it's all numbers less than 0. This is all numbers greater than 0. And the union is you combine them. So it's all numbers that are non-zero, basically. And so that's the domain. I've done a video on interval notation. Please check it out. Links in the description. If that confuses you, there are brackets, parentheses. You can completely demystify it by watching that video. But we've got that. And so here, you don't have to say it this way, but you can just say all non-zero numbers. And so when you draw the graph, you sort of know that when x is, I'm just going to label the axis, when x is positive, you do know that the function is going to go towards infinity because of this limit here, which is x goes to 0 plus of 1 over x is plus infinity. So you can sort of see that the graph is kind of drawn like this. Okay, so it sort of blows up. This red line keeps getting bigger and bigger very rapidly. It just gets as large as you like when x approaches 0 from the right. And when x approaches 0 from the left, it's going to be the other way. So it's going to kind of come like this. So this is kind of going to say that the graph gets arbitrarily close. The y value gets arbitrarily close to negative infinity as x approaches 0 from the left. So x is a negative number. And you can keep extending the graph, right? So one way people do this is via limits. But these are infinity and minus infinity limits, which I won't go into in this video. But just to kind of say, as x becomes really large and positive, 1 over a really large number is a really small number. So it's kind of the opposite phenomena. And you can kind of actually use that to explain why the graph kind of goes like this in that direction and similarly like this in that direction, okay? So this line y x equals 0, I'm just going to casually throw in some terminology. This is called a horizontal asymptote, okay? So we say, not a horizontal, a vertical asymptote at x equals 0, okay? So a vertical asymptote at x equals 0. What that means is that as x approaches 0, the graph goes to infinity or minus infinity. So in other words, it gets close to this line x equals 0 as x approaches 0. So this line kind of approximates the graph as x approaches 0. That's what it means, but we will discuss this in detail in future videos. Thank you so much for watching. I hope you loved that video and it gave you a really clear understanding of this limit. Drop me some comments down below. I'd love to hear from you. And please leave a like and subscribe. It means a lot to me that you've watched so far. My goal, I've taught this in Princeton University a lot, but my goal is to create videos in math at all levels that's freely accessible worldwide, not just to people in college or in high school, but everyone can access it, and by liking and subscribing, you really help me to achieve that goal. So thank you so much for watching. I'm super excited to see you in the next video, super excited to read your comments, and I hope this helps support you, and I wish you all the best. So see you soon.